All right, so this is part 2 of our logarithm study. And here we have what's called the common logarithm and the natural logarithm. So common logarithm is a base 10. It's called common. And instead of writing, let me write this. I'm going to type this for you so you can read. Instead of writing log with a subscript of 10 of something, okay, we just write log of something. So you have to kind of understand when there is no subscript, the understood base is 10. Now we have a base E logarithm, which is called a natural logarithm. E is for Euler, the guy who created this number. We would not write log base E. That would be a log base E. It's written as ln, which you'll find on your TI-84. These buttons exist on the TI-84. Let me pause this real quick. My kids are coming in from the snow. All right, so I'm back. Anyways, I say this often in class, and I 100% mean it. You have to understand the understood. Both of these are what we call understood documents, and you also have to take notes. So if anybody wants to tell Carson to go on YouTube and take notes, you probably should. All right, evaluate common and natural logarithms. What is the value of each logarithm expression to the nearest 10,000th? We could do these entirely in a calculator. These are calculator problems. So we're just going to fire up TI-84. And we just have to hit the right button, play along at home. Log 900, 2.97 some, and that's all you do. You type that in. They're not too hard. Now, one of these examples is kind of a learning thing about logarithms, because we haven't talked about domain of a logarithm yet. ln of e, the ln key is right there, right next to the 4 and 7, kind of halfway between. And what is it asking? It's the natural log of e. Now, by the way, since this was yesterday's lesson, what is log 900 asking? And I need to reinforce this idea of understood things. It's asking you what power of 10 creates 900. And it turns out it was like 2.9542. So let's just check that out. Which makes sense, because 10 cubed is 1,000, but 10 to the 2.9542. It's going to be pretty close. It's going to be a little under. Almost 900, right? I always take logarithms to the 4th decimal, and you should too. So kind of think that. Round to the 4th decimal. That's how I do logarithms. ln if you think about your understood stuff, there is an understood E here. So, we can do this one without a calculator. It's asking what power of E creates E. That is a question that you should understand. That would be 1. E to the 1st is 1, is E. But anyways, some of y'all will never figure out the understood. So ln, and then if you want the E, second ln, you just put E to the 1st. And it's going to return a 1. Now this example right here is trying to teach you something about the domain of a logarithm. Even though it's an ln, doesn't matter. The domain of a logarithm. So they've got log of a negative number, actually ln of a negative number. .87. My calculator ought to freak out when I ask this. It should not be able to answer this question. And it says error, non-real answer. So when you talk about the domain of a logarithm, for a logarithm of an argument a, the stuff inside has to be bigger than 0. And think about the context of this question. The original question was saying, what power of e creates a negative number? No, there's nobody coming over today. Sorry, talking to Mason. It's asking e to what power is a negative 1. I know you had a good time last night, buddy, but nobody's coming over. Now, Daddy's recording a video for my students. I need you to be quiet, okay?
What kind of video?
Just a video about mathematics, okay? And so anyways, back to you guys. There is no exponent that can turn a positive number into a negative number. Now, you might be sitting there like, ha ha, Milbrath, you're wrong. I can think of this. Push buttons in a calculator, kids. I'm not wrong about this. Yes, Mason. Well, then lay down and rest, Mason, if you're tired. All right, what is the solution to each equation? Round to the nearest thousandth. So now you actually get to do some logarithm equations. You're going to be using this whole context of log is bay. Like this is where it's at. Log is bay. So a logarithm, base b, argument e, has an equivalent inverse of the form b to the e equals a. So when you look at your equations, all you really have to do is just kind of identify what each part is. Bases have exponents, therefore this must be a base. This must be my exponent. It's a superscript. Superscripts are exponents, aren't they? Which means that this must be the letter A. You know, pause this video if you need to and see if you can make sense of what I wrote. So when I write this, I'm going to have a logarithm. Her base is going to be a 10. Her argument's going to be over here 25. The labeling is important, kids. Just pick up and label. And it must equal x minus 1. Now, this 10 here is what we call understood, right? So let's go see what my calculator says about a log base 10 of 25. It's 1.3979. 1.3979. 1.3979 is x minus 1. And I'm just going to add 1 to both sides here. Isolate my x. Some of y'all, God bless you, haven't figured that out yet. But 2.3979 is my x value. So it's not too hard. All right. Now, b, don't be that kid who types in ln of 2x plus 3 equals 4. We have to isolate that x, right? That's the goal. Isolate the x. You're probably thinking, well, Milbrath, there's an ln key. I'll just push buttons and I'll get it right. No, you won't. You got to isolate the x. Now, ln has an understood base of e. So that's a big deal. I need to put that little e there. All right? Then I'm going to go through and I'm going to label my parts. That little e is a subscript. It happens to be a base. Bases are low. This would be my argument, and this is my exponent. It seems weird when it's written in logarithmic form, but look up here. This is the most important thing about today's lesson. So now that I've identified all the pieces, I can rewrite it. It's going to be e to the fourth, base is e, exponent is 4, equals 2x plus 3. And I'm just going to go through the isolate x part. All right. So I'm going to subtract 3. You don't want to push buttons in a calculator yet because you'd get some funky decimal that equals 2 to the x. And now I'm going to divide by 2. So e to the fourth minus 3, sitting pretty over a 2. It'll take me a while to type that out. I apologize. But I'm at home recording this, and I don't have access to my board. And my touchscreen just doesn't write as well as my board does. And my handwriting's already pretty bad. That's my x value. Now, if I wanted the decimal, I can get the decimal. Let's see, we have e to the fourth. We're going to take away a 3. By the way, don't be this kid. Don't be that kid. I know who you are. You know who you are. That's wrong. See how I typed it in? You either got to use math num n over d, or you just got to do it in two parts. But here's e to the fourth minus 3, then divided by 2. And that's the correct answer, 25.7991. Ah, my cat just touched the keyboard here, sorry. X equals 25.7991. Again, round to fourth decimal. That's how I want you rounding. Just making sure I typed it in right. Didn't have a case of dyslexia or anything. All right, these are for you. These are straight up you tries. You try and do those. There are the base logs. What do we have here? Earthquake problem. Then we have writing an inverse. All right, in seismic energy, X in joules can be estimated based on the magnitude of an earthquake by the formula X equals 10 to the 1.5 magnitudes plus 12. What is the magnitude of an earthquake with a seismic energy of 4.10 to the 20th joules? Let's see here. So seismic energy is identified in the text as X, right? So let's do some substitution. 4.2 times 10 to the 20th must equal 10 with an exponent of 1.5 m plus 12. All right, so let's identify some parts here. This is my base. This is the base's exponent, which means this is my argument. So what I'm going to do is I'm going to convert into a logarithm. I'm going to have a log whose understood base, but I'm going to write it anyways, is 10. Her argument is 4.2 times 10 to the 20th power, which I'm just going to push buttons on calculator. There's probably one in the pantry, buddy. Give me a few minutes and I'll get it for you. Sorry, kid was asking for chips. Let's see what a log of 4.2 times 10 to the 20th is. And you shouldn't be too surprised by this answer. Well, I guess it didn't work out the way I thought it would. It's 20.6232. 20.63. Done forgot where I was. 6232. 6232. And that equals 1.5 m plus a 12. All right, we're going to subtract 12. We're going to have 8.6232, and that'd be 1.5 m. And then we're going to divide by 1.5. Yeah, I'm currently doing something. Please give me a few minutes or get it yourself, children. Then we're going to divide by 1.5. 5.7488. So the magnitude is, I'm currently doing something. Get it yourself or give me a few minutes. All right, there we go. I'm recording a video for my students to learn math from, Emmett, so I need some time, okay? All right, we are on the writing of the inverse steps. We did this in the previous unit. I don't think it went too hot. These were some of the last questions on a test you guys took before Christmas break, but these are the same steps as before Christmas break. This is how you write an inverse. You swap x and y, you resolve for y, you replace y with f of x. So here's an easy one just to kind of remind you. Remember, f of x is y. It's just a fancy way of saying y. It's understood that that's the way it is. So this y becomes an x, and this x becomes a y. That's step one, swap x and y. Step two is to isolate y, resolve. So we're going to take away the 5, and then we're going to divide by the 4. And that's supposed to be a 5 there, isn't it? Now, since I'm typing, I'm using parentheses. There you go. And the last step is to replace the y with the correct notation, because if you did not, nobody would know it's the inverse. So f raised to the negative first of x, the inverse of f of x. All right, here we have this guy. It says provided x is greater than 0. The reason it says x is greater than 0, greater than or equal to 0, is because if you thought about the graph of this thing, this is what it would look like. Oh, that's bad. And that is obviously not 1-to-1. So we erase the left-hand side of it. Oh, sorry, that's not the eraser. We throw away the left-hand side of it. We just keep the stuff where x is greater than or equal to 0. So we're just moving right. But anyways, same 3 steps. G of x becomes x. And everywhere I see an x, I become a y. We're going to subtract the 4. We're going to divide the 2 out. I wish I had my board at work. But I don't. And then we're going to do the opposite of squaring, which is square rooting. So in order to save myself a little time, I'm just going to do this right here. And I'm going to get rid of that. Gone. So there's what my inverse is, as long as I replace that y with the correct notation here. So let's see here. We need a new square root symbol. Let's go ahead and put the divisor key there. We have a numerator of x minus 4 and a denominator of 2. And we are replacing y with the inverse of f of x. Sweet. Moving forward, we did 2 old ones. Now we're on to today's lesson. This should be the last thing I do. It is. Except I'm going to add a you try in here because you need to be able to try. So let's follow our 3 steps again. If you don't know these steps, write them down. We swap x and y. We resolve for y. Part 3 is we replace y with the inverse of f of x, f to the negative first of x. All right, so let's do our swapping. This becomes x. We've got a fractional subscript, and that x becomes y. And we're going to do what's called exponentiating this equation. When you convert from a logarithm into an exponential expression, you're doing something called exponentiating. Sounds a lot like exfoliating, which is a word that you would only know if you were a woman or had been around women a good chunk of your life. 1/4 is your base. Your argument is what's inside parentheses, and this must be your exponent, okay? So 1/4 to the x. Oops. Oh, too early. It's too early to exponentiate. I almost made a mistake. See, your rule about logarithms only has a singular logarithm. See how there's an understood 1 here in front of that log? There's a 4 there. Too early. Milbrath, you almost messed up. First thing we got to do, kids, is we got to divide that 4 out. You have to isolate the logarithm first. I must be a little rusty. I'm not rusty. I would have caught her. All right, so what do we have? We have an x over a 4 must equal a log whose base is 1/4 that has an argument of y. And now I can go through the process of exponentiating as soon as I figure out how to type. There we go. All right, so this is going to be my argument. The 1/4 is the base. Oh, I did that wrong. This is my exponent. This is my base, and this is my argument. So my base is a quarter. It is getting raised to the x over 4. And that must equal y. Now, y again is f to the negative first of x. And we're done. Let's see here. Here's the next one here. Now, let's think about this log is bay conversion form. It only works if the base itself is isolated. So this guy has a problem here. The problem is there's a 4 there. And we'll see that in a second. So we're going to make that y and x. And we're going to make that x a y. Oh, you okay, Emmett? You just wiped out, bro. We're going to have to do some isolation. We're going to add 2 to both sides. Maybe. That is all messed up. All right. So what I'm trying to get y'all to see here is that this base is by itself, right? Or this logarithm is just one logarithm and this base is just one base. So the next step is going to be to divide that 4 out. And now I'm ready to actually do my conversion. And this is something that throws kids off. A lot of kids can do simple logarithms, but when they have to actually do manipulation, it gets pretty rough. This is going to be my base. That's where I changed colors there. This is going to be my exponent, which means that this has to be my argument. So it's going to be a funny looking logarithm. It is a log whose base is e, which we'll rewrite in just a minute. Its argument is going to be x plus 2 over 4. I wrote that like that because I'm typing, okay? And it has to equal y plus 3 because log is bay. The logarithm equals the exponent. Now, log base e is an understood concept, becomes ln. Yeah, it looked like it hurt, buddy. I'm glad you're okay. Almost done, May. So in between me talking to my kid here, what I did is I subtracted 3 from both sides because we're supposed to resolve for y. And the last step, since that y is by itself, is to replace it with the inverse of f of x. So let me make up something for you all to try. Write the inverse of what, Mason Lee? Mason, you'll have to give me a few minutes, okay, son? Let's just leave that 10 off there. 3 log of x plus 6 equal to f of x. And there is your u try. It shouldn't be too bad. It's a base 10 logarithm. And we'll do one other one where you have to go the other way. Write the inverse of, let's go with an e to the x plus 4. And just set it equal to, I don't know, let's call this one h of x. Not too bad. Let's put something in front of that e, though. Make you do at least one more step. And then let's take something away, too. There we go. So write those both inverses. Those are u tries. And that is it for this lesson. Sorry about the kids interrupting. They do that. And this was way too long because of them. Sorry.